Good morning, grade 11 students. In this session, we're going to review together the note that we have started before about the gene localization. We said that we have to verify that we have affected recessive allele. And pay attention to this. To verify affected recessive allele, we have to look to two normal parents. They have affected child, whether a daughter or a son. So by this way, we can prove that the allele is recessive. Okay? To verify affected dominant allele. Affected dominant allele, you have to look for two affected parents. They have normal child. So if the allele of the disease is dominant, so here we have to look for two affected parents. They have a normal child. By this way, we can prove that the allele of the disease is dominant over the allele of the normal, which is recessive. Most of the exercises we solve them, the allele of the disease is recessive. But today we're going to solve an exercise or an application where the allele of the disease is going to be dominant. Location of the gene autosomal, or it's found in the non-homologous part of Y, or non-homologous part of X, or the homologous part of X and Y as well. In this session, so in this session we're going to talk about a revision about these four cases. If in non-homologous part of Y, how can we prove it? On the non-homologous part of X, non-homologous part of X and Y, and autosomal. Let's start step by step. If you want to verify it autosomal, and I prefer to be the last one to verify it, all the individuals, males and females, they have the equal probability to be affected by the disease. How? Sometimes they mention this in the text. Sometimes they mention that a disease, for example, let's say albinism. Albinism is a disease where the males and the female they have equal probability to be affected by the disease. This sentence, maybe I'm going to ask you pick out from the text the sentence that show that this disease is autosomal. So this is the sentence that show that this disease is autosomal. Otherwise, to prove it autosomal, we have to deny three. We have to deny that's found on the non-homologous part of X. We have to deny that is found on the non-homologous part of Y. And also we have to deny that's found on the homologous part of X and Y as well. So here, to verify if the gene is located on the non-homologous part of Y, as I said before, at the non-homologous part of Y, only the males will be affected. Why? Because the Y. Why? Because the Y chromosome is found only in males. So if it's found on the non-homologous part of Y, only the males will have the Y. So only the males will be affected. So if we have only one female affected by the disease, this means that the disease is not found in the non-homologous part of Y, and this is not the case. Or you can solve it in another way. This is the simplest way to prove it, or to prove it that's found in the non-homologous part of Y. Or every affected son will have an affected father. Why? Because the father will transmit the allele YD, the YD for his son, which should be affected also with having YD. So the father is normal, so it's not the case. Also, to verify if the gene is located on the non-homologous part of X, every affected daughter should have an affected father. Every daughter which is affected should have an affected father. Why? Because the daughter has two X's. And the allele of the disease here, pay attention here, I'm talking about the allele of the disease is recessive. Okay? Now, whenever we move to the dominant, it will differ a little bit, and you have to pay attention there. So XD, XD. So this daughter should inherit XD from each of her parents. So should inherit XD from her father. So the father will have XDY. And this means that he should be affected. But if the father is not affected, So it's not the case. To verify if the gene of the disease is located on the non-homologous, in the homologous part of X and Y, the recessive daughter and the recessive son should have recessive father, and this is the case. Moving for this application, last time we said that 1 1 and 1 2 they are normal, but they gave birth to affected children 2 1 and 2 2. So from here, we can determine that the allele of disease is recessive. They said discuss logically the chromosomal localization or location of the gene. Before I continue with this discussion, I have to determine first the dominant and the recessive allele, and then I have to give the symbols. Then I have to discuss the localization. So here, without determining the dominant and the recessive, and also without giving the symbols, all your work will be cancelled, meaning that you didn't solve any of these parts. So you have to pay attention to this note. If I said discuss the chromosomal localization of the gene or the location of the gene, so here you have to determine the dominant and the recessive, you have to give the symbols, and then you have to discuss it. Otherwise, your work will be cancelled, even though you use the symbols correctly, but you didn't say what is the dominant, which one is the dominant and which one is the recessive, what does the symbol code for, and what does the symbol code for. So here you have to pay attention to this. So 1 1 and 1 2, they are normal, but they gave birth to children 2 1 and 2 2. These 2 1 and 2 2 they are affected. So here the allele of the disease it was masked in the normal parent. So it's recessive with respect to the normal dominant allele. Next, I have to give the symbols. Let's say M capital be the symbol of the normal allele which is dominant over the allele of the disease. Let D small, A small, C small, it's up to you. You choose the symbol that you want. Here in this exercise, I use the symbol N capital for the normal and D small for the disease. So here, let's discuss logically. First of all, if the gene of the disease is located on the non-homologous part of Y, who can deny it? Who can deny that's found in the non-homologous part of Y?
Um, if it was found on the non-homologous part of Y, then none of the female, then the daughter shouldn't have been affected.
So none of the females should be affected, Yarima. But what do we have in the pedigree? We have
But
2-2.
daughter two is affected by the
So
disease.
it's not the case. Okay? So first of all, we deny it on the Y. So here the Y is eliminated. So it's not possible to be on the Y. Let's move to another case. Let's deny it on the X. If it's found on the non-homologous part of X and the allele of the disease is recessive. So this daughter will be XD, XD. By the way, drawing the pedigree in front of you and writing these notes on it is very important during the quiz or during the exam. So here, XD, XD. So this daughter should inherit XD from each of her parents, from her father 1 1, XD, and from her mom 1 2, another XD. So this folder should be XD and Y. XD and Y, it has the allele of the disease on the X. And we are saying that if it's found on the X, so this father should be affected. But this father is not affected. So it's not the case. So here we deny it on both the non-homologous part of X, the non-homologous part of Y. Then let's move to the homologous part of X and Y. If it's on homologous part of X and Y, so this individual to 1 should have XD, YD, and this should have XD, XD. So here XD, YD, this individual sure will inherit the YD from his father. أكيد will not inherit it from the mother. So this is the YD. And XD from the mother. Here XD. And this daughter should inherit XD from the father and XD from the mother. So here it will be XD, XD, and the father should be XD, YD. And here both of them should be affected, but they are not. So it's not the case. So here the disease is said to be autosomal. So if they said to give the genotype, these individuals, 2 1 and 2 2, they are affected. So both of them should be B small, B small. Why? Because both of them are affected and the allele of the disease is recessive with respect to the normal dominant allele. So here we can say that this is the case where both alleles are recessive and should be expressed in the homozygous. Pay attention. Sometimes they're going to ask you indicate the genotypes. Indicating the genotypes, you have to say only the genotype. You said that the genotype of individual 2 1 is D small, D small. But if I said identify or verify or specify, all of them they are at the rhyme of Wi-Fi. So sure here you have to justify. If you didn't justify, meaning that your answer could be wrong again. You have to justify. It's obligatory. Since the verb it says this, you have to justify. And let's move. These individuals they are normal 1 1 and 1 2. So both of them they have the allele N capital for the normal, but they gave birth to affected children, so they should be ND and D. 3 and 4 they either an N or and D. Why? Because N or ND, both of them are normal, and the normal allele is dominant. It can be expressed in both homozygous or heterozygous. So this is the case of the genotypes of this pedigree. So here you can identify the pedigree and the genotypes as well. If I told you perform the essential factorial analysis, it's very simple to do so. Now let's move to the new pedigree, which is the complex pedigree a little bit. This is the pedigree where we have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the 12. So here, no need to put 1, 1, 1, 2, 2, 1, 2, 2, 3, 2, 4. You can say only individual 1, individual 2, individual 3. First of all, is the allele of the disease dominant or recessive? Justify your answer. Yes, let's move to Cynthia. What do you think? Is the allele of the disease dominant or recessive? So the one in the blue, they are the affected, and the one in white, they are the normal. Yes, Cynthia, what do you think?
Since parents 1 and 2
Yes,
are affected
yes,
and they Seman is
yes,
this
yes, Sama.
um and they gave birth to affected child 3.
Yes,
Um, so the allele of the disease is dominant, and the
over,
normal over
over,
the
which is,
recessive.
yes, over the recessive,
The
normal allele.
allele of the disease that is affected is dominant over the normal recessive allele, which
Very
was
good.
masked by the dominant.
Very good, very good. So Cynthia said that 1 and 2 they are affected, yet they gave birth to a child or to a daughter which is normal. So the allele of the normal was masked by the parents. So it's recessive with respect to the dominant allele coding for the disease. Here it's another scenario. Here it's another form. The allele of the disease is the one which dominant. So here the allele of the disease is the one which dominant. So here let's move to the symbols. So if you want to give symbols, if you want to, you can give an small for the normal, and you can give, for example, A capital for the affected or D capital for the affected. Let's see justification or the questions first. Indicate the dominant and the recessive allele justify. Discuss logically the chromosomal location of the gene of the disease. Give the genotype of the couples 5 and 6 and their children. First of all, before we start, they said indicate the dominant and the recessive. Cynthia gave the symbols of the dominant and the recessive allele. But me and Cynthia, we didn't give the symbol. We didn't give the symbol. We have to give the symbol. So we should. So let, if you want, for example, A capital, like I did, be the symbol of the allele coding for the affected dominant allele over the normal recessive allele. We let N small. So here, let's start step by step. So the normal, it's N small, and the affected is A capital. Honey, can you deny it on the Y? Yes, honey?
سمعنا يا أستاذ.
Yes, now I hear you. Yeah. So deny it on the Y, honey.
It's not on the Y
If the gene
since
of the disease is located on the non-homologous part of Y, you have to start like this. Okay? Yeah, repeat.
if the gene was located on the non-homologous part Y,
Okay.
then every male should be affected and the female should not be affected.
None of the females should be affected. Which is easier.
Yes,
None of the females should be affected, but
but individual 10, which is a female, is affected, so it's not on the
so it's not the
non-homologous part of
case.
Y.
So it's not the case. Honey, if you study the way how to answer, this will help you a lot. Instead of writing two sentences, if you study the way, you can write only one sentence and you can save time by this. Okay, honey?
Okay.
Okay, so here you can say if the gene of the disease is located on the non-homologous part of Y, so none of the females should be affected. But from the pedigree, individuals 2 and individual 10, they are affected. So it's not the case. Here I finished the first one. So it's not the case. If the allele of the disease is found on the non-homologous part of X. Yes, Lynn, what do you think? How can you deny this?
Um, if the gene of the disease is located on the non-homologous part of X,
Yes,
every affected daughter should have affected father,
every affected daughter should have an affected father. Okay,
but female can.
is affected. And her father
Yeah.
is affected too.
Mm-hmm.
But here, pay attention. I told you we have a different scenario here. The allele of disease is not recessive. The allele of disease is
Dominant.
dominant. So here, let's start step by step. If the allele of the disease is dominant, right? So here, what do we have? What is the genotype of individual 1? It has XY, and you said it's only on the X. So it should be XAY, right?
Yes.
And the female here should be XX. But her daughter here, it's XX also. So it should be normal. And the allele of the normal is recessive. So it should be XN small, XN small, right?
Yes.
So it should inherit N small from each of her parents, right? So here
Yes.
XN from the mother and another XN from the father. So the one that I wrote it here, XA, it's not correct, should not be affected. So it's not the case. since it inherited xn from here, and here it should be inherited xn, so it should be normal, but it's affected, so it's not the case. Pay attention here. The allele of the disease is not recessive. The allele of the disease is dominant here. That differs. يعني اللي قالتها لي now قالت لي every affected daughter should have an affected father. Yes, it works 100%. Where when the allele of the disease is recessive. But here, the allele of the disease is dominant. So here we deny it on X and Y. So here you can completely, if you deny it on the non-homologous part of X and the non-homologous part of Y, you can say that it is autosomal. No need to deny it on the X and Y if the allele of disease is dominant. So here it becomes autosomal. Autosomal, so here the genotype will be for individual 4 normal and N. And this one is normal also and N. And this one is normal and N. And this one is normal and N too. And this is one is normal, so and N. Since the allele of disease is recessive, sorry, the allele of the normal is recessive and should be expressed in homozygous. That's why I denote them as N. So these one are affected. So they should carry the allele of the disease, A capital and A capital. But they gave birth to normal, they should be heterozygous, AN and N. This one is normal. It can be either, sorry, affected can be either AA or it can be A, and it depends on the marriage and on other techniques. This one is affected, so it should carry the allele A capital, but he gave birth to individual 7, which is an N. So here it's a N. This one is affected, so it has also A, but he gave birth to individual 12, which is an N. So it should be A N. Individual 10 and 11, they can be either AA or they can be A and N. So they have two possibilities. This one is a tricky one. Why? Because you got used that the allele of disease is always recessive, but now the allele of the disease is dominant. That's why it's different a little bit in the cases of explanation and verification. So first part, since both couples 1 and 2 and are affected and they have normal child 4, so the gene coding for the disease is dominant over the normal gene. So let A capital be the symbol of the allele coding for affected dominant allele over the normal allele M small. Let M small be the symbol of the allele coding for normal phenotype, which is recessive with respect to the affected allele. So if the gene is located on the non-homologous part of Y, so none of the girls' honey should be affected, but 2 is affected, so it's not the case. Then, if the gene is located on the non-homologous part of X, so every normal daughter should have normal father here, since the allele is dominant here. Okay, so you have to pay attention to this. So every normal daughter should have a normal father, but daughter 4 is normal and should receive XN from her father 1, it should be normal. But from the pedigree, it seems to be affected, so it's not the case. Therefore, the gene is going to be autosomal, giving the genotypes for 3, give the genotypes of couples 5 and 6 and their children 5 and 6 and their children هن 7 and 8. يجي حدا بيقول لي 9 it's not their children. 9 is the female that married their children. So it's the wife of 8. So 7 and 8 only they are the children of 5 and 6. 9 is not one of the children of the couple is 5 and 6. So you have to pay attention to this. Okay? So here the couple is 5, 5 is affected, but he gave birth to normal, so it's AN for the normal, and AN for 8, which is affected. And here we finished everything related to the description about the localization of the gene and the dominant and recessive